Our first experiment is study of logic gates. In this first there is AND gate. The AND gate performs a logical multiplication commonly known as AND function. The output is high when both the inputs are high. The output is low level when any one of the input is low. Next, OR gate. The OR gate performs a logical addition commonly known as OR function. The output is high when any one of the input is high. The output is low when both the inputs are low. Next, NOT gate. The NOT gate is called an inverter. The output is high when the input is low. The output is low when the input is high. NAND gate. The NAND gate is a contraction of AND gate. The output is high when the both inputs are low and any one of the input is low. The output is low when both inputs are high. Next is NOR gate. The NOR gate is a contraction of OR NOT. The output is high when both inputs are low. The output is low when one or both inputs are high. XOR gate. The output is high when any one of the input is high. The output is low when both the inputs are low and both the inputs are high. Next, our second experiment is study of adders and subtractors. First is a half adder. Half adder is a combinational circuit needs two binary inputs and two binary outputs. The half adder contains two inputs and two outputs with the XOR gate and AND gate. It is the one output is sum and the another output is carry. Next is full adder. In full adder, we have three inputs and three outputs. There are two XOR gates, two AND gates, and two OR gates. Next is a half subtractor. In this, we have two inputs and two outputs. One is XOR gate, AND gate, and NOT gate. The output is differentiated into difference and borrow. The next one is full subtractor. There are three inputs and two outputs, two XOR gates, two AND gates, one NOT gate, and the OR gate. That output is difference and borrow. Our third experiment is design and implementation of code converter 1. First, we have to perform binary to gray code conversion. The MSB of gray code will be exactly equal to the first bit of the given binary number. In binary to gray code converter, there are 4 inputs and 4 outputs, and there are 3 XOR gates. Next is gray code to binary converter. There are 4 inputs and 4 outputs, 3 XOR gates. Our fourth experiment is design and implementation of code converter 2. First, we have to perform BCD to XS 3 converter. There are 4 inputs and 4 outputs. There are 4 NOT gates, 3 3 OR gates, and 7 AND gates. In this, the truth table is first 3 are don't care conditions and the all last 3 also don't care condition. Next is XS3 to BCD. In this, there are 4 inputs and 4 outputs, 4 NOT gates, 7 AND gates, and 2 and 3 OR gates. Our fifth experiment is design and implementation of parity generator. In this logic diagram, we have 3 inputs and 2 outputs, 2 XOR gates, 1 NOT gate, and then we have output as even parity and the odd parity.